Hello everyone, my name is Han Shenxiang, and this is question 1 of homework 11 in the probability and stochastic process course. And in this question, at first we know the stochastic process X is real and white sense stationary with autocorrelation Rxx tau, and the power spectral density is Sxxw, and we want to prove that the Rxx tau is real and even, and the Sxx omega is even and non-negative. And at first, we want to prove the compute the autocorrelation. The autocorrelation of X, the formula is the expected value of xt plus tau times the xt, and because xt is real, so the expected value of it is real. And we want to compute the to prove the even if the Rxx is even, the Rxx tau is equals to Rxx t plus tau. We could write it as this function, and it is equals to this expected value of xt plus tau times xt, and it is equals to, we could exchange their position, and xt times the xt plus tau, and is equals to the Rxx t and t plus tau, and it is the Rxx minus tau, so we could prove that the autocorrelation is even. And for the question B, we want to prove the spectral density, power spectral density is even and non-negative. For the spectral density, we could use the formula of it. The spectral density is the integral of the autocorrelation times the e to the minus j omega t and dt. It is d tau is tau, sorry, it is a tau. It is a Fourier transform of the autocorrelation, and it is equals to, we could use the aura formula to put the e to the power of minus j omega tau to the cosine minus the I sine, g sine, okay, also the g sine. It is equals to the Rxx tau times the cosine omega tau minus d tau minus the Rxx tau. It is I to the sine omega tau d tau. Because of the Rxx tau is even and the sine omega tau is odd, and the even times the odd is the odd, so the integral of the odd formula is is 0, so it is equals to the Rxx tau integral of Rxx tau times the cosine omega tau d tau, and it is equals to the 2 times 0 to infinite Rxx tau times cosine d tau, and cosine tau is equals to cosine minus omega tau, so we could know that it is Sxx minus omega, so the spectral power spectral density is also the even, and we want to prove that it is non-negative. So we want to know if xt transfer into h omega, and we could get the output yt, and we could compute the yt of the spectral of the yt. If the yt is the as spectral density of x, we know that the h omega would be the one of when the omega from omega 1 to omega 2, or otherwise it is 0. We could suppose it's this h omega, and we could get the yt is the function of xt, and to find the expect value of yt to the power of 2, it is ryy, and it is equals to the 1/2 pi times the minus to sxx omega times the h omega to the power of 2, and d omega, the integral of omega of this is ryy, and it is equals to sorry, it is not the autorelation of y, it's just the absolute of this, and it is equals to the 1/2 pi, and this part, the h omega to the power of 2, we suppose the filter is have the one value, so it is equals to sxx omega d omega, and for this formula it is equals to expect value of absolute yt to the power of 2, and it is bigger or equals to 0, so this formula is bigger and equals to 0, so the x omega is non-negative, so the sx omega is even and non-negative. That's all. Thank you.